In this video, I'm covering factoring trinomials completely. Make sure to check your announcements, know when all your due dates and deadlines are. So what I mean by factoring trinomials completely is I mean that sometimes when we have trinomials, you'll need to utilize factoring techniques twice, okay? Usually it's GCF and then either what I call double bubble method, which I have the procedure for here, or using that reverse box method that we've been practicing with factoring by grouping. So on these first couple of examples, I'm actually showing you how to factor with the double bubble method. All right. If you don't want to learn the double bubble and want to keep up with your reverse box, totally cool. Just this method is a little bit faster. It only works when you have a 1 as your leading coefficient. So it has to be, an imaginary 1 written here with the second power. All right, so what you do is you create 2 sets of bubbles. And you fill in an X and an X. This sign, which I've called the fall down sign before, falls down into the first parenthesis. And your choice sign tells you whether your signs should match within the parentheses or if they should be different, which we've talked about in the box method also. In this case, a plus sign for your choice sign means that you should have matching parentheses. The t-table here is pretty much the same thing. Since your A is 1, really AC is just the same thing as C here. So I'm finding what multiplies to make 9 with a choice sign of adding to make our B value, which is 6. So the two terms here that multiply to make 9, that add to make 6, are 3 and 3. Now, if these weren't the same numbers, the bigger number has to go with your fall down sign, which is something we talked about in reverse box also. Let's try it again. So here, make 2 sets of parentheses. Fill in your variable, right? A p times p makes p squared. My fall down sign is a negative. And with a choice sign of positive, that means that the signs in the parentheses must match. So I'm going to have a minus minus. So if I make my little t-table, I'm looking for what multiplies to make 14. My choice sign is adding, so I'm adding to make the 15 here, which would be 14 and 1. And again, the bigger number is going to go with that fall down sign. In this case, it doesn't matter because my signs match. It'll matter in our next cases, though. Once again, pair of double bubbles, variable in each. My fall down sign is a plus. Now a choice sign to make a negative 24 means I have to have opposite signs in my bubbles. So I need another negative here. So in my t-table, I'm looking for what multiplies to make 24. And this time my choice sign is subtracting. So I'm subtracting to make the 5. In this case, it's 8 and 3. So the 8 has to go with the fall down sign, and the 3 goes in the other one. One more time with this double bubble technique, and then we'll get into our other method. So there I am with my double bubble set up. Oops, wrong color. My choice sign's my fall down sign's a negative, and my choice sign's a negative, which means that my parentheses have to be opposites. On my t-table, I'm looking for what multiplies to make 38. And my choice sign is subtracting, so I'm subtracting to make the 17 in the middle. In this case, it's 19 and 2. And that 19 goes with my fall down sign. So that double bubble method just eliminates the reverse box, spares you from some GCF factoring. Not too bad. Now I have this here flow chart to help you to make decisions, okay? Notice that you start with your GCF, and then you figure out the number of terms, okay? If there's still 2 terms after you do a GCF, see if it's a difference of squares. Otherwise, you can't factor it further. If there's 4 terms, you're going to factor by grouping, which is that reverse box method. If there's 3 terms, if your A equals 1, you can use this double bubble method, which is faster, or you just go hog wild with the reverse box here. Remember, There is the square of sum and difference formulas, which we cover in our next lesson, but you've also seen before, which could speed up the process. All right. So the first step, right, is always to look for a GCF. 6, 36, and 42 are all multiples of 6. So I divided 6 out. So when I did that, this gave me the ability to do the double bubble method, okay? So my GCF of 6 is going to hang out in front, and I'm double bubbling the stuff that's left here on the inside. So double bubble means that you fill in your variables. My fall down sign is a plus. My choice sign's negative, which means that these parentheses have to have opposite signs in them. So I'm looking for what multiplies to make 7, and then my choice sign is a negative, so what subtracts to make 6. Well, 7's prime, there's only one set of numbers that can go there. So the 7 is the bigger number, so it goes with your fall down sign, and the 1 goes with the other one. So here's your factored form. If you took that GCF out, he has to be in the front. Don't go losing him somewhere. Let's do it again. Now notice on this, these all have exponents, like really high exponents. So I'm actually going to be taking out x to the 4th because that's the lowest power to get this into a constant form. 12, 54, and 60, they're all even, but I think I can go a little higher. They're all divisible by 6. They're all multiples of 6. So when I divide 6x to the 4th out, I get 2x squared plus 9x plus 10. Okay, so I can't use double bubble because my a is not 1. I have to use this one. So I'm checking to see if it's sum of a square or difference. The way that you check is you look to see first if these are perfect squares. They're not, so we're going to factor by grouping. That's the reverse box. So I set up a box. I got my 2x squared and my 10. So when I come to the side here, a times c is 20. Okay, notice the GCF is not part of a times c. So I'm looking for what multiplies to make 20 that adds to 9. That would be 4 and 5. So we're going to break up that 9x into a 4x and a 5x. All right. So factoring out my GCF, I see an x, a 2, a 2x, and a 5. So my final kind of factored form, okay, I have the 6x to the 4th that was my GCF. Then I have my 2x plus 5 and my x plus 2. So see how I had to factor it twice? I had to take out that GCF and then I had to use my box. That's all that we mean to factor completely. All right, looking at these bad boys, they're all divisible by 3, right? Those are all numbers divisible by 3. So if I divide the 3 out using my green, because that's what I was using for our GCFs, I get this. Now if I look, this trinomial, 3 terms, my a is 1, so I can actually double bubble this. I don't have to use the reverse box. All right, so my fall down sign is a negative, and my choice sign is positive. So that means that to get a positive 22, I have to have a negative times a negative. Now 22 is composite. There's only 2 sets of factors that multiply to make 22. And the set that adds to make 13 is 11 and 2. And there we are in that fully factored form, remembering to put the GCF in front. Again. Now this one, I right away see that they're all even, but I can go a little bit higher. All right, 4 can go into all of these. So remember, it's not just the common factor, it has to be the greatest common factor that you could pull out. So the biggest number. So when I divide that 4 out, that's going to give me this trinomial. My a value is 2, so that means that I have to do the reverse box. So there I've put in my a and c terms. So a times c gives me 6. My choice sign is adding, so I'm looking for what multiplies to make 6 that adds to make 7. And that's 6 and 1. My fall down sign is positive, so the 6 has to be positive. The choice sign is positive, so these guys have to match in signs. And then when I take out my GCF, I have a 2x, a 1, an x, and a 3. So my final factored form, okay, is the GCF that I took out in the beginning, the x plus 3 from up top, and the 2x plus 1 from down the side. All right, last one. This one's 4 terms, okay? With 4 terms, you have to do the reverse box. But I'm starting with my GCF. I do notice these are all even. I like to go to the smallest number, which is a 4, and see if I could divide it out of all of these. 4 can't go into 6 and 18, so my GCF in this case is going to be a 2. So when I do that and divide it out, I get 9p cubed. Oh, that's a weird looking 6. P squared plus 3p minus 2. And those are the expressions that are going to go in this box. 4 terms is kind of nice because it's already, the middle term's already split for you, so you don't have to do extra work. As a lazy person, that brings me joy. All right, so going down my columns, I see a 3p. Again, that leading term's negative, so I have to take out a negative 2 here. This one's a 3p squared. And that's p squared, right, because the lowest power here is squared. And 3p minus 2, the only thing you could take out of that is a 1. So my final factored form is the 2 from my GCF times the top of my box times the side of my box. And there we have it, friends. That is factoring completely.